Hello everybody, this is Jeremy from White Mountain Science here with another robotics training talk. Today we're going to be talking about the gyro sensor built into the Spike Prime hub. We're going to be using it today to follow a straight line and to make very exact turns. All right, so let's dive into the coding and focus on the turning part of the gyro sensor first. So the Spike Prime hub, as I said, has a gyro sensor built into it, and it measures several different kinds of angles. We're going to be using the yaw angle for this challenge because yaw angle measures side-to-side movement. When you set the yaw angle to 0 at the beginning of your code, if you want to turn 90 degrees left, you would set the yaw angle to -90. And if you want the robot to turn 90 degrees right, you would have the yaw angle go to +90. All right, so let's jump into the code. So the basic challenge that I'm going to be working on is having the robot go to the end of a first robotics table and turn around and come back. In order to do that, I'm going to be using a line follower to get there. I'm going to turn about 180 degrees, and then I'm going to use the straight line function of a gyro sensor to come back. At the very beginning of my code, I'm setting the yaw angle to 0 so that when I get to the end of the table, I'll know how much to turn around in order to come back. The actual turning part of this code is right here. So I'm going to be running the motors in opposite directions until my yaw angle is above 175. And if you'll notice here, I use the absolute value of the yaw angle instead of just the yaw angle, because you can see here at this yaw angle, as it approaches 180 or a half circle and goes over 180, it actually switches to negative numbers, which would very much mess up my equation if I'm looking for a number that is greater than a positive value in order to turn. Next, let's use the yaw angle to drive in a straight line. So I've used a color sensor to follow my line to the end of the table. I've turned around, and now I want to come back. And I'm actually going to use the same code that I would use for a color sensor to get back, except I'm going to be using the yaw angle instead. So let's take a look at that. So here's my go home function. I'm going to set the yaw angle to 0 again. And this is the block that's going to get me home. So essentially what this means is I know I need to maintain an angle of 15 degrees in order to get back to base. Now, if my yaw angle is 15 degrees, I'm going to be driving straight because turning is set to 0. If my yaw angle goes above 15 degrees, if I'm moving too far right, say it's 30 degrees, that means that this equation is going to be -15. Which means that I'm going to be turning a little bit to the left to correct. Similarly, if my yaw angle is 0, that means this is going to be positive 15 degrees. So 15 degrees of turning. So I'm going to be turning a little bit to the right to correct myself. All right, it's following the line. It has a yaw of 0. It's already reset. It'll turn on the third line, resets yaw again, and then follows 15 degrees. And as you can tell, it's swaying back and forth as it continues on the 15-degree track. For this test, I'm doing a little bit something different with the gyro sensor. My robot is completing one of the challenges, and instead of turning around, my robot is instead just going to drive backwards. And using the same gyro sensor that follows a straight line, it can do that just as easily. Unlike the color sensor, where the color sensors are in the front, and that can affect the navigation on the return trip.